Hey guys, this is Mrs. Christensen. I can't be there today, but I have for you a video lesson of 7.2, which is going to be solving exponential equations. So let's get started. So here we're on lesson 7.2. Solving exponential equations. All right, so here, some of the notes that we need to follow. Number one, we need to use properties of exponents to simplify each side of the equation. Number two, we need to rewrite the equation so both sides have the same base. And number three, we're going to drop the bases and set the exponents equal to each other. I'm going to show you what this means now. Okay, so with our first example, it says 2 to the x plus 1 equals 2 to the 9th power. We can proceed here because we have the same base of 2. What we get to do is we can take these exponents, x plus 1 and 9, and set them directly equal to each other and solve. So we're going to do x plus 1 equal to 9, and then we just do the easy algebra of that, subtract 1 from both sides. X equals 8. And that's our answer. That's all we have to do. Really easy when the bases are the same. All right, let's take a look in case you need to see that. Make sure you can pause the video at any time if you need to catch up with taking notes. On number 2 here, we have 5 raised to the 4n plus 5 power equal to 5 to the n minus 7. Again, we have the same base of 5, making this really easy to go from here. So we're going to take these two exponents and set them equal to each other because 5 to a power has to equal 5 to that same power. That's how we know that these powers must be equal. So we're going to do 4n plus 5 equals n minus 7, just the exponents there. If we subtract this n from both sides, we now have 3n plus 5 equals negative 7. And now we're going to we're going to subtract 5 from both sides here. And that's going to give us 3n equal to negative 7 minus 5, negative 12. Divide both of these sides by 3, n equals negative 4. And that's all we have to do. All right, we are going to skip number 3. And we're going to skip number 4. All right. So now we're moving down to type 2. These are equations without a common base. So as we can see in number 5 to begin, we have 6 raised to the 2x minus 10 power equal to 36. As you can obviously see, 6 and 36 are not the same. So what we have to do is kind of play this game of what can we change these two so that they match. And we're going to take this 36 here, and we can change it to 6 with a power of 2. Therefore, it would have a 6 base with a power of 2, matching this 6 base with that power. So we're going to have 6 to the 2x minus 10 power equal to 6 to the second power. This is something where knowing your squares is really going to help you out. Now it goes back to what our type 1 is, where we have the same base. So what we can do is we can take this exponent, 2x minus 10, and set it equal to this exponent 2. So we have 2x minus 10 has to be the same as 2. Let's add 10 to both sides. 2x equals 12. 2x equals 12. Divide by 2 on both sides. That means that x equals 6. All right. All right, number 6, here we go. We have 2 raised to the power p minus 7 equals 8, okay? 2 is raised to a power, which means we need to change this 8 into something 2 to some power, okay? And as we know, 2 cubed is 8. So that's going to be our go-to here. We're going to change this 8 to base 2 with a power of 3. That's what we're replacing this number with. So it now becomes 2 to the p minus 7 power equal to, instead of 8, 2 cubed. Same base, p minus 7 has to be the same as 3, set those equal. P minus 7 equals 3. Add 7 to both sides, p equals 10. There you go. All right. This one's a little bit different. Number 7. We have, let me move up a little bit. What we have here, we have 7 raised to the power 4x plus 11 equal to 1/7. Okay. Now, if you notice, they both contain 7s, which is great. However, 7 and 1/7 obviously not the same. So what we have to do is we have to think of this. We need to know that 1/7 is actually 7 to the -1 power. Because that -1 is what makes this 7 go under the numerator and become a denominator. That's what a negative power does, if you recall from those exponent rules. So knowing that, we now have 7 to the 4x plus 11, didn't change, equals 7 to the -1 power. 4x plus 11 equals -1. Subtract 11 from both sides. 4x equals -12, because -1 minus 11 is -12. Divide both those by 4. X is -3. A little bit different, like I said, but if you can remember that 1 over a number is that number to the -1 power, that's how it's going to get you out of that troubled area. All right. Here we go, getting into some bigger numbers now. 32 equals 2 to the 2m minus 9 power. All right, this 32 has to change to 2 to something power. So this is where you would play around on your calculator, plug in some numbers until you figure out 2 to what power is 32, especially if you don't have those memorized. You know, and one thing you can do, you know, if you start doing, you know, we know 2 cubed from before, we know that's 8. So it has to be bigger than that. 2 to the 4th is 16, so it's not 2 to the 4th power. 2 to the 5th, bingo, that's 32. And that's something you're just going to find from playing around in your calculator or having these memorized. That's the only way you're going to get that number. So let's change this 32 here to 2 to the 5th so that these bases match. So 2 to the 5th power equals 2 to the 2m minus 9 power. All right, same base, 5. The exponent 5 has to equal 2m minus 9. Work through the algebra. We're going to add 9 to both sides. That means 14 equals 2m. Divide by 2. 7 equals m. And remember, you can always get these notes on Canvas if this video goes too quickly. All right, number 10. We are going to skip number 9 here. Number 10, we have 4 to the y plus 2 power equal to 16 to the y minus 3 power. Let's change this 16 to a 4 to something power. And we know 4 squared is 16. So that's what we're going to do here. We're going to change this. It's a little bit different though, because this 16 is not alone. He already has a power of y minus 3. So we're going to do the first term, doesn't change. Bless you. We're going to keep that as 4 to the y plus 2 power equal to this 16 is 4 squared still to the y minus 3. Now we have to do it like this because this square on the 4 is going to affect this y minus 3. Now if you remember your exponent rules, because this is a power raised to a power, this 2 and this y minus 3, they are going to multiply. Okay, so you got to think about doing the distributive property, 2 times y, 2 times negative 3. So again, this left side, not going to change. We're going to have 4 to the y plus 2 equal to 4 multiply 2 times y, 2y, multiply 2 times negative 3, negative 6. Same base, take those two powers, set them equal. We have y plus 2 equals 2y minus 6. And now let's add 6 to both sides. So if we add 6 here and here, this is going to become y plus 8 equal to 2y, and we added 6 and got rid of that. And now we're going to subtract this y from both sides, leaving us with an 8 all by himself equal to this y. If we have 2y, subtract a y, equal to y. So again, a lot like the other ones, the only thing we had to do is an extra power to a power exponent rule, an extra step in there. All right, let's flip to the next page. All right, let's see. Number 11. Guess I can get rid of my paper underneath, don't really need that. Okay, 125 to the y power equals 25. All right. Well, this one's a little different because you can't take 25 and make it to a power and get 25, or we can't do anything with that. Both of these have to change. So both of them are going to use their root base of 5 and become 5 to a power. Okay? Now here's what's going to happen. So if we do 5 cubed, that's 125. And you should know that 5 squared is 25. So we're going to use these substitutions in here. All right, let's start with the 5 cubed. So let's change 125 to 5 cubed. However, it's not just 125, it's 125 to the y power. So this is going to be 5 cubed to the y power. So let's throw parentheses around that and bring it up to the y power. Equal to 25. Nope, it's now 5 squared. All right. Power to a power, this would be 3y, and this would be 2. So let's do 3y equals 2. Y equals, divide both sides by 3, 2/3. You take your time on these, I don't think you can go wrong. All right. Number 13, here we go. 4 to the 3x power equals 8 to the x plus 1 power. Again, we're going to have to change both of these because we can't do change 8 as 4 squared or anything like that. So what we're going to have to do is we're going to have to bring these both down to base 2. All right, so a little side note, 4 is going to be 2 squared, and 8 is going to be 2 cubed. Okay, all right, let's make these changes now. So let's change 4 to 2 squared. So we're going to have 2 squared, but the 2 squared is raised to the 3x power, so put it in parentheses, 3x equal to not 8, but 2 cubed. And then that's raised to the x minus 1 power. So you can see in parentheses, that's where the 4 went, that's where the 8 went. It didn't disappear, it didn't change quantity, it just changed the way it looks so that we can manipulate it and solve this. All right, here we go. 2 times 3x is going to be 6x equal to this exponent power, which is 3 times x minus 1. Make sure you do 3 times the x and times the negative 1. So 3x minus 3, because that power gets multiplied by both. All right, if we subtract 3x from both sides, subtract 3x from here, it's gone. Subtract 3x from here, that becomes 3x. Then negative 3 is left. Divide both sides by 3. X is negative 1. Alrighty. I think this is the last one we're going to go through today is number 16. Focus, focus class. Oh no. Okay, there we go. All right, big numbers here. 27 and 243. All right, you might not recognize 243, but is a power of 3, and 27 is a power of 3. So that's what we're going to go with here, okay? Now playing around on your calculator, you know that 3 squared is 9. You multiply that by 3 again, you get 27. So you're going to figure out that 27 equals 3 cubed. Okay, and 243, if you work your way up, it's going to be 3 to the 5th power. Okay, again, doing this kind of by playing around in your calculator. All right, so let's change this 27 and this 243 to 3 cubed and 3 to the 5th. So first, the 27 becomes 3 cubed, and that 27 is raised to the 2x power, equal to 243, which is 3 to the 5th. So let's change that to 3 to the 5th power, and it's raised to the x minus 2. So let's have x minus 2 here. All right. Same bases, we have some power to power things we have to multiply. First, 3 times 2x is 6x, equal to this power, which is 5 times x minus 2, distribute the 5. 5x, 5 times negative 2 is negative 10. All right, let's subtract 5x from both sides here. And we're left with x equals negative 10. All right, and that's it. We're going to skip numbers 17, 18, 19, and 20. Okay, what I want you to do is finish up these notes and work on some of the homework.